In today's class, let me teach you how to solve an integer programming problem. An integer programming problem is nothing but a linear programming problem, and the method of solving a linear programming problem is applied to integer programming problem also, and the method is simplex method only. But while we solve the given integer programming problem using simplex method, we may get the values of the decision variables or the non-basic variables as fractions, as rational numbers. But it is insisted that the values of the decision variables have to be integers. Integers in the sense that the decision variables can take the values 0 and any natural number. Know that they should be only positive, and therefore I say that the decision variables can take the value 0 or any natural number except the fractions or the rational numbers. Okay. Now, see, if it so happens that in your linear programming problem, the decision variables, all the decision variables have to be integers, then it will be called as pure integer programming problem. It is called pure integer programming problem. And if the integers and rationals also come, that means what? The decision variables can take rational numbers and also integers, then such a problem will be called mixed integer programming problem. So there are two types of integer programming problem. One is pure, that is, if all the decision variables have to be integers, it is called pure integer programming problem. And if it is required that they can be the decision variables can be mixed, in the sense that they can take rational values and also integers, then such a linear programming problem will be called as mixed integer programming problem. And the method employed here are almost the same. There are two types of two methods are employed to get the integer solution. In the sense, what I mean to say is that we solve the integer programming problem in the usual way, applying the normal simplex method, but we will end up with the decision variables which are rational numbers also. But when rational numbers come, it is necessary that they should be changed to integers. The method of changing the rational values to integers is I told you that there are two methods. One is called cutting plane method. And another one is branch and bound method. And another method is called the branch and bound method. In this particular method, cutting plane method, what we do is we get the solution. As I told you, we get the solution to the given integer programming problem. The values for the, that is, we solve it. I should say that we solve the integer programming problem using the ordinary simplex method. We may get, or we will get, the rational values for the decision variables, but the rational values have to be changed to integers, for which we employ the first method, which is called the cutting plane method. In the cutting plane method, what we do is After getting the solution using the linear simplex method, we will create constraints. We will create constraints, and the constraints will take care to see that it eliminates the area where the integer solution is not available. Okay, and then it will take us to the integer solution. It may so happen that you may have to construct more than one or two or three constraints to eliminate the area where the integer solution is not available and take you to the integer solution area. Now this is a method, and the constraint that is constructed for eliminating the area which does not have the integer solution is called the Gomorian constraint. It is called the Gomorian constraint, and this constraint it is because of the mathematician who gave us this method of doing it. So you see that this is a Gomorian constraint. We will construct the Gomorian constraint and eliminate the area which does not have the integer solution. Like that we go on doing it unless and until we get the integer solution. This is the method. But in the branch and mode method, we create more problems. That is, in the sense, we create when rational values comes, we split it into two problems and we search for in the area where we get the integer solution. So the process will go on and on unless and until we end up with the integer solution. I will elaborate on this particular method when time comes, but this method, I will use this method to solve this particular problem. As I told you in the beginning itself, use ordinary simplex method to get the solution for this. See, the method is, I have in my previous video, that is in dual simplex method, I have given elaborate explanation on how this simplex method is done, how the simplex method is carried out in a problem, and please go through that video and you will understand better. And if you have a good knowledge on the simplex method, now that you will find it easy to understand. The difficult part comes only when you are going to convert this integer to that is a rational solution to integer solution. That part I will be concentrating on more to teach you very clearly how you should do that. Now till then it is a normal process, or the method is known to you only. So let us start doing this now. So this is an introduction to the problem. Now I will take up this. Now here when you are solving this, then you have to write this problem as max of z is equal to x1 plus x2 subject to conditions. See, here it is no 3x1 plus x2, 3x1 plus 2x2. Be carefully writing this. Even if you're omitting or doing something wrong while writing the problem, we will not get. So this is a big difficulty in solving these linear programming problems. You have to be very careful writing the numbers, signs and everything, otherwise you will not get the answer at all. So you see that this is a less than or equal to symbol. So what we do is we add a slack S1 which is equal to 5. As I told you, I used to explain to my students, suppose I say that 4 plus 3 is equal to 8. So you see that this one shot is nothing but you add 1 here. Since I do not know anything about this, I put simply as S1, and this S1 is called a slack variable, and S1 is greater than or equal to 0. That is, it has to be a positive quantity, it can be, at the least it can be 0. So this is the slack variable. So the introduction of slack variable comes only when it is less than or equal to. By chance, if it is greater than or equal to, then it is a surplus variable. For example, you see that 5 plus 2, then I say that it is 8. Then you must subtract, it is 6. then you have to subtract this 1 because here it is more. See, if it is greater than means you have to subtract to get this number. So this subtracted variable will be called as your surplus variable, and we will talk about this when the time comes. When we take a problem where this greater than or equal to inequality comes, I will explain more elaborately on that. Now coming to this, so you see that now I'll write this as, so here you see that the second one is, it is 0x1 plus x2 is less than or plus a constant plus s2 is equal to 2. Now you see that in order to be more careful, what I do here is s2 is also coming, so I'll write it as s2. This is equal to your 5, and here again, you know, what I do here is that 0s1 plus s2 is equal to 2, and you have got x1 x2 s1 s2 greater than or equal to 0, and here 0s1 0s2. Now we are going to prepare the iteration tables. You know what is called iteration means repeat. Iteration means a repeat. We are going to iteration table means a table where these particular whatever be the data that we have got put here, it will be put as data in the iteration table, and your working will be done. And while you work, that is in the working, we try to get the solution. The table is worked out in order to get the solution to the problem. Now you see that while you work out in the way, that is as using the simplex method, you will see the table will tell me. That is while you work out using the simplex method, the table itself will tell you whether you have arrived at the optimal solution. That means it will tell you the figures that you get, or the working will tell you that whether you are arriving at the optimal solution. So when that condition, it will say, that means optimal solution would be got satisfying a certain condition. If that particular condition is not satisfied, then we say that the optimal solution has not been obtained. So the process has to be carried out. That means what? You try for a solution, you improve the solution, but you are not satisfied. That's your working says that it is not satisfied and you must go for further process. That means you must go for the second iteration and do the process, and the condition may not be satisfied, telling you that it has to be still more improved. So you go on doing this unless and until the condition finally says that, optimal condition says that yes, the problem is over and you have got the final solution. It may so happen that you will not get a solution. There may not be a solution for the given problem also. So that can also happen. See, for which I can give you a lot of practical examples, but since when time comes, I will tell you how it should be understood. Okay, now, so you see that this is what we are having. I will put this in an iteration table, and iteration table is a standard table. Once I teach you how to do the working in that iteration table, the second then the subsequent iterations have to be prepared using the same method that I teach you for the in the beginning. That is, I teach you something in the beginning, and for the other iterations the same principle have to be used to prepare the tables. So I'll teach you how to do that. So you see that here I will write here. So this is a standard form: CB, YB, XB, and this is CJ, and these are all notation. YB means it is for the basic solution column, and CB means I will tell you all these things. So you see that X1, X2, S1, S2. So this will tell you that CJ means here the coefficients that are coming in the objective function, it is 1, 1, 0, 0. And here you see that how now we will see. Now you see that before preparing this initial iteration, you must be able to get the basic solution. That means a starting solution must be there. Let it be totally wrong or anything, but don't get a negative solution. For heaven's sake, don't get a negative solution. If you are getting a negative solution, it is called an infeasible solution, and the treatment itself is different. Let us not talk about that now here. Here what you have to do is, having done this, you must be able to get the initial solution. That initial solution should be used in the initial iteration table, and then only you have to do the working and then start improving the solution. You are able to catch what I am telling you. So you see that how do you get that initial solution? So basic, initial, basic, feasible solution. Initial means initial, beginning. Basic means the basic, the first basic solution. Okay, then feasible means a solution which is non-negative. Okay, it can be 0, but it should not be negative. Feasible solution. So IBFS means initial, basic, feasible solution. Now if in order to get this, what you have to do is see how many variables are here. 1, 2, 3, 4. N is equal to number of variables is equal to 3. Number of equations, see what is that? M is number of equations is equal to 2. So take away this, 4 minus 2 is 2. So make 2 variables 0. I'll repeat this. You find out how many number of variables are there. Here in this case 4 variables are there, and you have got 2 equations. So subtract, that is, call this n as number of variables, m as number of equations. Subtract, you will get some number. That number of variables have to be made as zeros. Here in this particular case, you see that there are 4. It is 4 minus 2, as I have written here, to make 2 variables 0. Normally you have to necessarily make the decision variables. What are the decision variables? x1 and x2 as 0 in this particular problem. There may be, you will come across problems, even the slack surplus variables. You may get surplus variables which have to be taken as zeros. Now in this particular case, you see that x1 is equal to 0. You take x1 is equal to 0 and x2 is equal to 0. So you call this as your 1, call this as your 2. Put x1 is equal to 0, x2 is equal to 0. This is 0, this is 0. So your s1 is equal to 5, and you get s2 is equal to 2. So this is 0, this is 0, s2 is equal to 2. So this s1, s2 are called the basis. It is called the basic solution, basic variable, and the solutions are 5 and 2. This is what I am going to write here. So your s1 and your s2 are the 2 basic variables that are going to come here. So this YB column is for the variables, basic variables or non-basic variables. It is for the variables here. And what is S1 CB value? S1 CB value is 0. S2 CB value is 0. Now write this equation. XB, this is your XB. Try to understand. This is your XB value. These are all your XB. So here XB is equal to 5, 3, 2, 1, 0. And next one is, it is 2, 0, 1, 1, 0, 1. Now you see that you get 3x1 plus 2x2 plus 1s1 plus 0s2 is equal to 5. First equation. Then 0x1 plus 1x2 plus 0s1 plus 1s2 is equal to 2. So you are getting the second equation. So this is what you get. Then you see that Cj is nothing but what? The coefficients of the variables in the objective function. So what is that here? The Cj stands for what? The coefficients of the variables in the object. This is your objective function. Z is your objective function which has to be maximized. After then, what is that you do is, these things, as I told you in the beginning itself, the elaborate explanation or the working method has been fully explained in my previous video, which while doing a dual simplex method. The method there may be different, but I have made mention of this, the method of simplex, that is the simplex method, while explaining the dual simplex method also. So go through that video patiently, you will understand this one well. Okay, now coming to this is CB multiply CB. See, 0 into 5 is 0, 0 into 2 is 0, so this is 0. This is ZJ minus CJ. So this is, now here you just see that, then 0 into 3 is 0, 0 into 0 is 0, 0 minus 1 is minus 1. Go through this, I have explained, that is why I am doing it very patiently here. Likewise, 0 into 3 is 0, then 0 into 2 is 0, 0 into 1 is 0, then take away 1, so this is 1. Then this is 0, this is 0, take away 0, this is 0, 0. Now, as I was explaining to you, this is your initial iteration. I means initial iteration. So you see that in this initial iteration, I have prepared the table. And this table tells me, now you must read from the table whether you have got the optimal solution. As I told you, a condition has to be satisfied in order to make sure that, or make certain that the solution is the problem is over and you have got the optimal solution. Your optimal solution is here. This is called your ZB. This is called your ZB. ZB value is equal to 0. This place is for Z1 C1, like that this place is for what? Z4 minus C4. So this is for Z. So this place is for Z1 minus C1, this is plus Z4 minus C4. This. So you find that this optimal solution is ZB is equal to 0. Naturally, that means you are assuming a solution which is 0. Now that here, now you see that here this is a positive, ZB value is positive quantity, here ZB value is a positive quantity, therefore they are called feasible solution. The solution is feasible. That means what? It is a non-negative. If only when it is non-negative, we call it as a feasible solution. Okay, understand that. Now coming to this, check this. Z1 minus C1, Z2 minus C2, Z3 minus C3 and Z4 minus C4. If all are greater than by a positive quantity or equal to 0. At the worst it can be 0, but it has to be a positive quantity. If all are positive quantities, Zj minus Cj, Z1 minus C1, Z2 minus C2, Z3 minus. If all are greater than 0 positive or can be 0 also, then we say that the Zb that we have got is maximum. That means optimal. I will not call it as a maximum, it is the optimal solution. Even if there be one Zj minus Cj, which happens to be a negative quantity, then we say that the solution is not obtained. You pass on to the next iteration. Are you able to understand? So the condition is here that your all Zj minus Cj must be greater than or equal to 0. That is Zj minus Cj greater than or equal to 0 for all j. Even if there be one Z1, Zj minus Cj for one value, if it is negative, then you must pass on to the next iteration for using a certain procedure or a principle of doing that I will teach you now. Now I have taught all these things in, as I told you repeatedly, you just watch that video, you will understand. But I am repeating this again because to make you understand better. Okay, now coming to this, so let me rub off all this. Let me rub off here after. I don't want this. Now you see that the process will remain the same, process of doing will remain the same. Now you see that how do you determine? Now what is that you must know? This S1 and S2 are called the slack variables. They are helping you to solve the problem, and as such it is not, they are not solutions. Understand that variable. S1 and S2 are mere slack variables which do not form a solution to our problem. They are just mere, they help us to get the solution, and they are not themselves solution to the problem. So you see that S1 and S2 I don't want. I am more bothered about getting it's a non-basic variables X1 and X2 which are the solutions. So I must try and bring in the YB column so that I will be getting my solution. So this is what you must have in your brain. Okay, now coming to this, Now my question is how to, now what is that? I must bring in some variables in the YB column. So that will be called as an entering variable. So in simplex method, first we have to find out which is going to be R. Now as I told you here, this is negative and this is also negative. So it means that our optimal solution has not been obtained. That is, you are making sure of that. We are very confident of that. Now what should we do is, so we have to bring some variable in the plane YB column so that it will form a solution to our problem. Because I am more worried about only getting the solution to my problem, which have to be either x1, x2 or both. That you must understand. Okay. Now, so you see that I have to bring in a variable. I have to bring an entering variable. We call it as entering variable. This is called entering. This is called our entering variable. See, what is our entering variable? Entering variable, I'll teach you what it is. Now, you just goes through this. Z1 minus C1 is negative, Z2 minus C2 is negative, all others are zeros, don't bother about that. If they are positive quantity also, don't bother. Now, Z1 minus C2 is C1, Z2 minus C2. You just compare their negativity. See, I am using that word negativity, which has got the, so you must choose that column wherein the Zj minus Cj is more negative. That is comparatively. It is the most negative, I should say. If there are 3 or 4, the most negative. Here you see that you compare this Z1 minus C1, Z2 minus C2, whichever is maximum negative, that column must be chosen. For example, let us suppose that here you are having minus 1 and here you are having minus 2, means minus 2 is most negative. By value it may be small, but it is most negative, so you have to choose your x2 column. But in this particular case, you see that both are minus 1 and minus 1. Without loss of generality, I will choose this x1 column as my, that means what? This x1 column is my entering variable. That is, this is called my key column. I will use only small abbreviations because of space. So this is my key column. That is, KC means key column. And then you see that, so I am totally confirmed that my x1 variable will come in the YB column. That means x1 comes here. Okay. Now when x1 comes, some other variable must leave the table. That means from YB column, another variable should go away and this x1 must replace that place. Okay. So which is going to go? Either s1 is going to leave or s2 is going to leave. That is my question. Okay. For which what we do is, I give a certain, this is called your theta. It is xbi divided by AIR, and I make it I write it here, AIR is greater than 0. Now you see that, what is the meaning of this XBI? XBI means, this I refers to the rows here. XB value is here. See, XB, this is your XB value. See, this is your XB. This is your XB value. This is your XB. Here I will write. So you see that here this is your XB column and I refers to the row. So XBI means XB column, I refers to row. Okay. Now coming to this AIR means, this AIR, yes. I refers to row here. I refers row here, or refers to that key column. What is that? I refers to that row. It may be row 1 or row 2, and or refers to the key column. Now which is your key column here? Your x1 column is your key column. And XBI, when you come to this first row, come to the first row, in the key column it is 3 and it is 5. So I should find the value of 5 by 3. Keep that with you. And here the next one is 2 and the corresponding value is 0. Find the value of these two. Whichever is going to be minimum value, whichever fraction is going to give you the minimum value, that particular row must be chosen. Are you able to understand? That is, what I mean is, you find this value xbi divided by air, you find all the values and take the minimum, and that minimum value row must be chosen as your key row, K-E-Y, key row. That must be taken as your key row. That must be taken as your key row. Now in this particular problem, you see that here you are getting this AIR as 0, but I told you here it must be greater than 0, so don't consider this. Don't consider this at all, because here it is 0, so don't consider. So which is the only option that you have got? The only row that has been given, so this is your row. And this is called your key row. And this is called your key row. Now, so the key row tells you that that particular variable is going to go away from the YB. That means it is a leaving variable. So S1 is leaving variable. What is that? So S1 is leaving variable and X1 is entering variable. Having determined that, now we have to change all the equations now. This first equation must be changed, second equation must be changed, and Zj must be changed in order to pass on to the first iteration. Okay, are you able to understand how that is done? I will tell you. Okay, now are you clear how this entering variable is done, how the leaving variable is done? And now, having found that it is our job to form the new equations. New equations means what? Like this, you have to form new equations, then call them as iteration 1. That is for this and also for Zj minus Cj. How that is done, I will tell you. See, I will write it clearly here. So this is, which is entering variable? X1. So this X1, this will be called as new pivot equation. New pivot, see, it is like this, new. This is what I am writing it as new pivot equation. So this is new pivot equation. So what I do is I form the new pivot equation. How do you write this? Which is your, see, you write this 5, 3, see, it is 5, 3, 2, 1, 0. XB, X1, X2, S1, S2. And which is this is called your key element. This is called your 3 is your key element. Now this is your key element. Divide everything by 3. So what is that you will get here? 5 by 3, 1, 2 by 3. So this is your new pivot equation. So your new pivot equation is for the variable, non-basic variables x1, and this is called your pivot equation, new pivot equation. Now, so we have found, this is what then old, you have to change everything, old S2. What is your old S2 here? 2, 0, 1, 0, 1. With regard to this, with regard to S2, which is your key element here? 0. And what is that you will do? Take away 0 into new pivot equation. So what is that? This is your new pivot equation. Huh? So 0 into this, 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 and then subtract. Are you able to understand? 0 into this, 0 multiplied by 1, 0 multiplied by 3, 0 multiplied by 1 by 3, 0. Everything you put below and then subtract, you will find that 0, 0, 0, 0, 0. So what is that you get here? So new S2 is 2, 0, 1. So this is what you get. And then old Zj minus Cj. What is that? 0, minus 1, 0, 0. Here you see that with regard to this minus 1 is your element. Multiply this, minus 1, minus 5 by 3. Minus 1, minus 2 by 3, minus 1 by 3, 0. Then subtract. So minus 1 into new pivot equation and then subtract. So this will be 5 by 3. This will become plus 0. This will become plus, and this is minus 1 by 3. And this is minus 1 by 3 will become plus 1 by 3. This is your. So this is what we get. Now you see that, so we have formed the new equations. Now having formed the new equations, I can put all this, write this x1 equation, s2 equation, and also this new Zj minus Cj in the table as here. That will be called as your iteration 1. Even without preparing the iteration table also you can do. But for your understanding, because you may not be able to so conversant with this, that I do this for you. That is, I prepare the table here. So you see that what is that you will get here. So I'll rub off all this. So this is your first iteration. So I initial iteration. So first iteration. Now you replace here now your x1. What is the coefficient of x1 here? So x1 is 1. And what is this rightfully here? 5 by 3. Then 1, 2 by 3, 1 by 3, 0. Then this is written. Then this one S2. 0, 2, 0, 1, 0, 1. Here 5 by 3, 0, minus 1 by 3, 0. Now, this is my first. Now ask yourself a question. What is that question that you will ask? Have I completed the problem? Is my problem over? The problem, whether the problem is over or not depends on the optimality condition. First of all, you see that these are all feasible solutions. Don't worry about that, because you will get only feasible solution. But the important check that you must do is whether this Zj minus Cj are all positive or 0. Now you see that this is ZB value. Don't bother about this. This is ZB value. This is Z1 minus C1, 0. Don't worry. Z2 minus C2 is minus 1 by 3. Z3 minus C3 is positive. This is 0. But the only negative value is Z2 minus C2. So what is that Z2 minus C2? It is a negative value. See, Z2 minus C2. This is a negative value. So it tells you that the problem is not over. That is, this we have not obtained the, see, ZB value is 5 by 3. 5 by 3 is not your optimal solution, because you must go for still more processing, because here the optimality condition is not satisfied. I will tell you, I'll connect this problem with a graphical solution. I will teach you the graphical method of doing the, if it is required, I will use the graphical method for this problem, and I will give you the comparison of this graphical solution with simplex method, and tell you how this optimality condition works in the graphical method, how this optimality condition works in the graphical method, that I will tell you. Now for the time being, understand that Z2 minus C2 is a negative quantity. It means that the optimal solution has not been obtained. So see, this is the only column Z2. So you see that this will be your what? Round off like this. This is your key column. As I told you, this is your key column. And which is the entering variable here? X2 is the entering variable. So you have found the entering variable. Now you have to find the leaving variable. How to find the leaving variable here? Go to the first row. What is the XB value? 5 by 3. Divided by the AIR, ith row key column element 2 by 3. So this is equal to your 5 by 2. 5 by 2. Come to this. This is your XB value is 2 and divided by 1. This is 2. Now 5 by 2 is 2.5 and your 2 is there. Which is minimum? 2.5. Definitely 2 is less than 2.5. So this is minimum. So this particular row is key row. So this is your minimum. 2 is. So this is your this thing. Now which is your key element? So this is key row and this is your key element. Now having found the new key element, the same process must be done. Are you clear now? So I am not going to teach you something new. The same thing as I have done here will be done here. Now in order to go pause on to the first iteration, doing this process I will pause on to the iteration 2. So this we will start doing this. Okay, now I will rub off this. So you see that what do you get here now? So what is that you get here? So what is your new pivot equation? New pivot equation. What's the new pivot equation? X2 is your new pivot equation is your, see, X2 will come and this is our this one. So sorry, 2 0 1 0 1. I'm sorry. So this is the leaving variable and this is the entering variable. So I must write this X2 and which is your key row. I'm sorry, this is key row. Now you see that here the key element is 1. Therefore you see that what is that you will do? Divide throughout by 1. See, divide throughout by 1. 1 1 1 1 1. So what is your X2? It is 2 0 1 0. So this is your new pivot equation. Okay, this is your. Now this is what we get. Now what is your one? Now you tell me what's your old X1 now? What's your old X1? What's your old X1? It is old X1 is 5 by 3, 1 2 by 3, 1 by 3 0. Now what is the key element with regard to this? In this column it is 2 by 3. 2 by 3 into 2 is 4 by 3. 2 by 3 into 0 is 0. Again it is 2 by 3. It is 0. Then it is 2 by 3. Now you do the subtraction here. So new X1. 5 by 3 minus 4 by 3 is 1 by 3. 1 0 1 by 3 minus 2 by 3. Okay, then old Zj minus Cj. What is your old Zj minus Cj? 5 by 3. Here it is 0 minus 1 by 3, 1 by 3 0. Now this is the key element with regard to this row. So minus 1 by 3 into, see, this is your new pivot equation. See, minus 1 by 3 into new pivot equation, take away that. So minus 1 by 3 into 2 is minus 2 by 3. Minus 1 by 3 into 0 is this. Minus 1 by 3, it is like this, minus 2 by 3, 0, minus 1 by 3, then it is 0, then it is again it is minus 1 by 3. Now you do the subtraction here. 5 by 3, if you take away this will become plus, so 7 by 3. This is 0, this is 0, this is 1 by 3 and this is 1 by 3. Now you see that I am getting a new. So here you need not, you can decide yourself whether you have obtained the solution to the problem. You see that only see this Zj minus Cj. Zj minus Cj, leave off this is your Zb. Z1 minus C1 is 0. Z2 minus C2 is 0. This is positive, and therefore we have obtained the solution for the linear programming problem. Are you clear? See, I will write this. See, I will write this. So this second iteration I am writing here. So what is my second iteration? CB, YB, XB, CJ, X1, X2, S1 and S2, and this is 1, 1, 0, 0. And what is now your X2? So this one you must write, this one you must write, this one. What is your X2 here? X2 coefficient is 1. Write this 2, 0, 1, 0, 1. Then X1 is also 1. Then you write this 1 by 3. Then it is 1. Okay. X1, yes. X2 is 2. Okay, whatever it is. 1 by 3, 1, 0, 1 by 3 minus 2 by 3. Then you are getting here. It is 5 by 3, 5 by 3. It is 5 minus 4, 1 by 3. Okay. Then what is that you get? Zj minus Cj. It is 7 by 3. It is 0, 0, 1 by 3, 1 by 3. This one, yes, this is 2. Then 2 by 3, 4 by 3, it is 1 by 3, this is correct. And 2 by 3 plus 1 by 3, correct. So you see that here this is a iteration, second iteration, which is tells you that we have obtained. See, Z1 minus C1, Z2 minus C2 are all, see, we must be very careful doing. So you see that Z1 minus C1, Z2 minus C2, Z3 are all positive. Optimality condition is satisfied, and therefore my solution is, what is that? So solution is, I'll rub off this. So my solution is what? So the solution to the problem is, see, ZB is equal to max of Z. What is that? This is what you, 7 by 3. For X1 is equal to what? 1 by 3. X2 is equal to 2. Now see, you write this. X1 is what? 1 by 3. X2 is 2. 2, 3 by 2 by 3 is what? 7 by 3. Are you able to understand? So this solution has been obtained. Now let me ask you a question, whether the problem is over? No, the problem is not over, because you see that here it is said that, I have not written here, and X1 and X2 are integers. X1 and X2 are integers. That means what? X2 is an integer, okay, but X1 is not an integer, and therefore this is not the solution. Up to this simplex method I have taught you. So the problem is over. But here X1 is equal to 1 by 3, X2 is equal to 2. So this is not the solution. As x1 is equal to 1 by 3 is not an integer. So use cutting plane method or Gomorian constraint method. So let us use this Gomorian constraint method to arrive at the solution. Now how to do that I will tell you. See, be carefully observing me or watching me so that you will understand. So let us start doing this. Now you see that first of all you must choose that variable for which you have to construct the Gomorian constraint. I'll repeat this because as I told you in the beginning of the class itself that when you are not getting the integer solution, you may have to construct additional constraints. Like we call those are constraints. These are all constraints. So like that, you must be able to create the constraints. That constraints will be called as Gomorian constraints, and they will take care of eliminating the region which do not have the integer solution and take you to the integer solution. So that is the idea behind. Now you see that here when you are finding that this one, you must be able to choose that row. I'll repeat, choose that row. So you must be able to choose that row which will be called as the source row. That means what? You have to choose source row. You have to choose that source row with which you can construct an additional constraint called the Gomorian constraint. For that, the method is like this. See, what we do is, see here you take this xb1, write it as xb1 plus f1. For xb2, you write it as xb2 plus f2. Or xb3, you take it as xb3 plus f3. All are fractions. Fi's are fractions lying between 0 and 1. Naturally, it should not be negative quantity and it cannot be more than 1. So they have to be. Now you compare this f1. Choose, see, minimum, maximum of f1. Take the maximum of f1, f2, f3. See, let us say fk. Let us say fk is the maximum. Then choose the kth row as your source row. What is that? If fk is maximum, then kth row is source row. Then kth row is source row. Are you able to understand? So you write this. These are all xb values. This is the xb value. Take the xb values and this is your xb value. So take the xb values and write it as this means integer. You write it as a positive integer plus a fraction, positive integer plus a fraction, and choose maximum of all f1, f2, f3, up to fn, and if fk is your maximum fraction, then that kth row should be taken as your source row, and that source row must be utilized for constructing the additional constraint called the Gomorian constraint. I gave you the spelling Gomorian, that is called the Gomorian constraint. Now let us come here. Now let us come to the problem. Here this problem is simple, therefore you will not find it difficult. What's your xb1? xb1 is what? 2. So 2 can be written as 2 integer plus 0 fraction. Then xb2 is 0. 0 integer plus 1 by 3. Now f2 is greater than f1. So you see that f2 is greater than f1, therefore naturally source row is what? So this is source row is 2. So your second row must be taken as your source row. Use that row to construct the Gomorian constraint. Now I'll tell you how it should be done. Carefully watch and follow the because in optimization normally in these linear programming problems, if once a method is taught, you have to follow the method again and again. That is again and again. You cannot deviate in any way. So I am going to teach you a method of doing it. That method, whatever problem comes for you in the examination, you must stick on only to that principle while tackling a problem, that is integer program. In this particular case, integer programming problem means you are finding using the Gomorian constraint means this is the method and you follow the method. Whatever be the problem that comes in your examination or you are asked to do a problem, use this method only. Are you clear now? So let us now see method of constructing. I will tell you the method of constructing. So this is your source row. Now write the equation of the first what is the step 1. I'll just tell you because you can hear and you can keep it in your memory. It may not be necessary for me to write on the board. So what is that you will write the first step? Write the source row equation. What is that source row equation? It is 1 by 3 is equal to 1 into x1 plus 0 into x2 plus 1 by 3 into s1 minus 2 by 3 into s2. Okay, after writing this, carefully watch what I am telling you. After writing this, what you have to do is you see the coefficients of all the variables. On the right hand side you have got xp. Every coefficient must be written as an integer plus a fraction. What is that? An integer plus a fraction. If it is a compound fraction means what? Say 3 by 2. 3 by 2 means what? 1 plus 0.5. Suppose if it is going to be like this, 12 by 7. So what is that you will write? 1 plus 5 by 7. So you see that this is 1 is an integer and 5 by 7 is a fractional part. So you must write all those in that form. So here what is that you will write? Since this is already a fraction, don't worry about that. This is integer, this is also integer, plus if it is a positive fraction means what? A fraction which is necessarily, it is less than 1. You know very well. So if it is a positive fraction, whatever be the fraction, leave it as it is and keep it with you. That means what? This 1 by 3 is a positive fraction, so you keep it with this. Then plus. So you see that if it is a negative fraction, write it as a negative integer plus positive fraction. What is that I have written here? If it is a negative fraction is there, then you must be able to write it as a negative integer plus a positive fraction. Now here it so happens that what is your this fraction? It is minus 2 by 3. Minus 2 by 3, you must express this as a negative integer plus a positive fraction. Now how will you write this negative? See, what is 2 by 3? What is that? Forget about minus. 2 by 3, what is the next highest number integer? It is 1. So you write it as 1 minus plus add, because I want a positive fraction. So 2 by 3 means it is less than 1, but immediate highest integer is 1. So I have written here that must be negative. And plus you add something, it is a positive fraction, so that when you do this arithmetic simplification, you must get again minus 2 by 3. That means minus 1 plus 1 by 3 is equal to minus 2 by 3. So in this place, you write it as minus 1 plus 1 by 3 into S2. Now you see that I have not altered anything. Here this minus 1 instead of minus 2 by 3 I have written like this. So what is that you get here? Now you again write all these things. 1 by 3 is equal to 1 into x1 plus 0 into x2 plus 1 by 3 into s1, then minus 1 into s2 plus 1 by 3 into s2. Now after doing this, you drop off all the integers. See, I am giving you the method of doing it. Okay, you drop off all the variables which have got integral values, that is integer values. Wherever the coefficients of integer, drop them. And what is that you will do? Here drop it is not required, it is not required, it is not required. Then you write this as half of s1 plus 1 by 3 of s1 plus 1 by 3 of s2. You will find that this is greater than or equal to 1 by 3. 1 by 3 of s1 plus 1 by 3 of s2, that is the sum of the variables will all be greater than the constants on the right hand side. Here the constant is on the left hand side. So you see that the sum of the variables will be greater than the constant on the other side of the equation. So you see that 1 by 3 of s1 plus 1 by 3 of s2 is greater than 1 by 3. So this tells you that throw it multiply by minus sign. Don't cancel this 1 by 3. Minus 1 by 3 of s1 minus 1 by 3 of s2 is less than or equal to minus 1 by 3. You multiply through it by minus sign. Now as you know that if it is less than or equal to, you can add a slack. A slack variable can be used. So this is equal to minus 1 by 3 of s1 minus 1 by 3 of s2 plus a Gomorian slack. This is equal to minus 1 by 3. G1 is Gomorian slack and this is Gomorian constraint. So this is your Gomorian constraint and this is your Gomorian slack. Now how to proceed then? After then, this particular equation has to be inserted here. That means what? In the final, this one, see this has to be go here. That means you have got the second iteration as the final one because we got the solution for the problem treating it as a LPP. In that particular second iteration, final iteration, include this, insert this as a third row and use the dual simplex method and solve. I will tell you why you should use the dual simplex method. So what is the procedure? Having determined the Gomorian constraint, you insert that as your additional row in the final row of your of the problem, and then apply the dual simplex method to get the solution. I'll repeat this again for those who are viewing this. I'll repeat. After finding the Gomorian constraint, insert the Gomorian constraint as a third row in this case third row in the final iteration, in the final second iteration was our final iteration, and use dual simplex method to solve the problem. Now let me do this. So I'll rub off this. See what is that? We will read the problem. So here you see that. Okay, now you see that here you are going to you have introduced a new slack. So this new slack should come here as 0 and its value is also 0. Now in x2 there is no, in x2 there is no Gomorian slack is coming, therefore its coefficient is 0. So here it is 0, 0, 1, 0, 1. And for x1 also there is no Gomorian slack comes, so you see that it is 0. Know that. Then you have to insert this. What is on the xb value? This is your xb value, so that is minus 1 by 3. And what is this? YB? It is G1. And what is the value of G1 here? 0. Okay, then write the equation. Now in this equation you don't find x1, so 0 x1. In this you don't find x2, so 0 x2. But minus 1 by 3, minus 1 by 3, and it is 0, and it is 0. Now you see that? So this is what you get here. So you see that here I am inserting this here, taking G1 as 0 and writing this equation here. X1 is absent, 0. X2 is absent, 0. Other things I have written here. G1, why I put G1 means if it is compelled in the problem that I have to go for another Gomorian constraint, means I will call that Gomorian constraint slack as G2. This Gomorian slack here is G1. If in the problem it is required that I have to construct another Gomorian slack, means Gomorian constraint means that Gomorian slack should come, and that slack will be called as G2 only for that. Okay, now this is what I have done. This will not change. The Zj minus Cj value will not change because it will remain the same, and this is what we have. Now you see that here why I calls a dual simplex method. Use, I'll write here. Use, why I should use dual simplex method? Because can you see this? G1 value is minus 1 by 3. Minus 1 by 3 means an infeasible solution. What is that? Infeasible. INFEASIBLE. It is an infeasible solution and the optimality condition is satisfied. Here it is 0, it is 0, 1 by 3, 1 by 3. All are either positive or 0. Therefore, optimality condition is satisfied, but it is an infeasible solution. Since it is an infeasible solution and optimality condition is satisfied, use the dual simplex method, for which the procedure is go to the XB column, see all the negative values coming, and among all the negative values choose the maximum negative. This is the procedure. I have done a problem on dual simplex method in my previous video. You can go through that and you will find all these things are explained. Okay. Now here in this particular case, only one row is there with the infeasible solution. So this is your key row. This is your, and what is that? Here you see the having found. That means here I am finding the leaving variable. That means G1 will leave YB. That means G1 will leave the table and it will give space for the entering variable. Now we have to find what is that entering variable. Okay. Now entering variable is found as this. Just compare this with your ordinary simplex method. Here I will use a theta which is equal to Zj minus Cj divided by Akj. Okay, okay. What is that K? Akj means Ke refers to your key row and J means column. See, K refers to here the key row and J refers to column. Now you find the value of theta Zj minus Cj and the condition is Akj must be less than 0 and choose minimum, that it is maximum of Zj minus Cj divided by Akj. Now what is that you will do? Here Z1 minus C1 divided by, this is your key column. Z1 minus C1 divided by this. Z2 minus C2 divided by this. Z3 minus C3 divided by this. Z4 minus C4 divided by this. Z5. So like that, here the understanding of this is that these are all your Akj values. Divide the Zj Cj minus Cj values by the Akj. That means the corresponding key row. So you see that key row is this. So Z1 minus C1 divided by this. Z2 minus C2 divided by AK2. Z3 minus C3 divided by AK3. Z4 minus C4 minus AK4. Likewise the other one. But the only condition is your AKJ values should not be 0 or a positive quantity. If they are 0 or positive quantity, don't consider. Okay, in this case, don't consider this, don't consider this, don't consider this, consider only these two. So what is that you will get here? So this one will be Z3 minus C3 is 1 by 3 divided by minus 1 by 3. Z4 minus C4 is 1 by 3 minus 1 by 3. So this is equal to, what is that you get here now? It is theta is equal to, so you want this maximum. See, I'll write here. Maximum of maximum of minus 1 and minus 1. So minus 1 is the maximum. But either you can choose this or this. Any of these two you can choose. So let me choose my S1. So what is the variable coming here? S1 comes and G1 leaves. Here afterwards, the same method, that is forming the pivot equation, new equations, and then passing on to the next iteration. The same as we have done in the simplex method. Same method I have to use to get to pass on to the next iteration. What is that you will do? New pivot equation. So S2 is the incoming variable, entering variable. S2 enters, G1 leaves, and S1 enters. This will be a reverse in the simplex method. In simplex method, we will find out which is the entering variable first and then the leaving variable. In dual simplex method, we will find the leaving variable first and then the entering variable. So what is that you will get here? So new pivot equation is S1. Take this S1 means what? Take this G1 and divide throughout by, see what is your this one? So this one. So this is your key element. So it is minus 1 by 3. It is 0, 0, minus 1 by 3, 0. So this is, now divide throughout by minus 1 by 3. Divide throughout by minus. So it is 1, 0, 0, 1, 1, 0. So this is what you will get. Okay, now old x2 2 0 1 0 1 0, xb x1 x2 s1 s2 g1. Then which is your key element here now? 0. So this is your key. 0 into this is 0. So this will remain the same. So this is old and new. Because you see that right here, this 0 is your key element with respect to this. Multiplied by throughout this key element, new pivot equation. And 0 into anything is 0. Then old x1, what is your old x1? 1 by 3, 1, 0, 1 by 3, minus 2 by 3, 0. Now what is your key element here? 1 by 3. Multiply 1 by 3, 0, 0, 1 by 3, 1 by 3, 0. Subtract 1 by 3 minus 1 by 3 is 0. This is 1, 0, 0. This is minus 2 by 3 minus 1 by 3 means minus 1. This is 0. Then What is your old Zj minus Cj? It is 7 by 3, 0, 0, 1 by 3, 1 by 3, 0. Now which is your key element here? 1 by 3. 1 by 3 into 2 by 3 is 2 by 3. 1 by 3 into 1 by 3 is 1 by 3. 1 by 3 into 1 by 3 is 1 by 0, 0. See, 1 by 3 into 1, 1 by 3. 1 by 3 into 0, 1 by 3 into 0. 1 by 3 into 1 is 1 by 3. 1 by 3 into 1 is 1 by 3. 1 by 3 is 7. Now you do the subtraction. It is 2. 0, 0, 0, 0, 0. Now, here I have found the new equations for all x1, x2 and Zj minus Cj. Now, I have prepared the new equations. Now, I can go to the third iterations. I can prepare the third iterations. Before writing that itself, you can very well get confirmed that whether you have got the solution, whether your problem is over. See here, Zj minus Cj are all zeros. Either they should be 0 or positive quantity. That means optimality condition is satisfied. So I am, and then what is the value of x1 here? New x1. x1 value is 0. And new x2, where is your new x2? Old x2 and new x2. So old and new. Old and new x2. So this is your x2 value is 2. That means what? Your x2 is 2, an integer. x1 is 0, which is also an integer. And that optimality condition is satisfied. So the problem is completely over. We have solved the problem as an integer, pure integer programming problem, because x1 is 0 and x2 is equal to 2, and that we have got the solution and all the conditions are satisfied, and therefore we have obtained the solution and the problem is over. And we will put the table here. Now I will prepare the table here now. CB, YB, XB, CJ. It is 1, 1, 0. Now you will write this. So you can start writing with x2, or you can write x1. Whatever you want to write, no problem. There is no hard and fast. For x2 it is 1. For x2, 2, 0, 1, 0, 1, 0. For x1, 0, 100, 1. Then S1, 0. It is 2. Then 0. So the problem is over. See, Zj minus Cj are all greater than or equal to or zeros, and so the condition is satisfied. x1 is equal to 0, x2 is equal to 0, and your problem is over. Now I have forgotten to give you the check. When you prepare the table, you must ensure that your table is correct, or your calculation, your numerical calculation and everything in finding the new equations are correct. How to ensure that means, what is that you must do is the usual procedure I have taught you. 1 into 2 is 2, 1 into 0 is 0, 2 plus 0 is 2. So 2 we have got. 1 into 0 is 0, 1 into 1 is 1, 1 minus 1 is 0. So I have got 1 into 1 is 1, 1 into 0 is 0, 0 into 0 is 0, 1 minus 1 is 0. I have got. Then 1 into 0 is 0, 1 into 0 is 0, 0 into 1 is 0, so I have got here 0, 0 minus. Then 1 into 1 is 1, 1 into minus 1 is minus 1. If you add, it will become 0. This 0 into 1 is 0. So that is also 0. So here 1 into 0, 1 into 0, 1 into 0, take away. So I have that full. So this is a check. This is how you must verify. In previous tables also, for iteration 1, iteration 2, iteration, whatever be the iterations, previous iterations, 2 iterations, you should have checked. Please check yourself, verify yourself whether adding like this, 1 into this, 1 into this and add, then 1 into this, 1 into this, 0 into this, take away this. Yeah. So if you check, go for that particular check and find out whether your all Zj minus Cj or coming in the, or the values that you have got by the separate calculations here, by the separate calculation. If you get the same thing, then they are correct. Otherwise, you have committed wrong and you will not get the answer. So this is the answer. So what is the final answer now we have got? So we have got the answer. So the problem is over. So ZB value is ZB, which is equal to maximum of Z is equal to 2 for x1 is equal to 0.